Hello everyone. Thank you for attending the master degree class for the electricity consumption optimization in K-means clustering algorithm. This paper is Hyunung Choi and Professor Naomed Muad Farakirsh and Professor President Dong-Yeol Shin, Sungwon University, South Korea. Online. First, the introduction, and second is related work. Third is proposed approach, and fourth is evaluation, and fifth is conclusion, and sixth is references. Introduction. This is using the UC-Irvine machine learning library and analyze the electricity consumption from power grid from the UC-Irvine library, and then I use the optimize using the scikit-learn and then K-means clustering algorithm and analyze for the best fit for optimization. Optimize the find the best fit for using the Shiller score and Shiller score and Kornis-Karabas index and Davis-Burdett index and find something. In the power grid, we measure the consumption through the sensors: industrial consumption, housing consumption, factories consumption, and housing consumption, front end consumer end, back end electric company end. Introduction continues. Back end company end dataset for the consumption from UC-Irvine. UC-Irvine dataset is the best for the machine learning test, and it's it's cleansing for all the machine learning data and easily can experiment easily. So many techniques that solve the optimization problems electricity, but none of them focus on the housing electricity optimization. Reducing cost, the factor of charge, prediction are not available. So many techniques that solve the optimization problem of electricity, but none of them focus on the housing electricity optimization. Reducing cost, factors of charge, prediction are not available. Introduction continues. Solution: using the K-means algorithm. Why choose the K-means cluster? And this is the why choose the K-means cluster and predict the answer from dataset. No any answer is available in terms of K-mean. Why predict the answers? No clearly. In this paper, electricity usage of home is analyzed through K-means clustering algorithm. For obtaining the optimal home usage electricity usage of home is 3A is analyzed through K-means clustering algorithm. For obtaining the optimal home usage electrical data point, the Kornis-Karabas index, the Burdett index, and Shiller score, find the detailed optimal number of cluster in the K-means algorithm and present the application scenario of the machine learning algorithm. 3B is reducing the A per one dataset result the same result. The proposed approach delivers us efficient and meaning prediction results never obtained before. Related work: machine learning. A way to learn machine with data values. Number one, several ways such as 2 and 3 and 4. K-means clustering. One of the methods for the machine learning algorithm under the unsupervised learning category of use. It is a main task of experimental data mining and a common technique for the statistical analysis used in many fields. Number 6 and number 7 and 8. Community feasibility assessment. Cluster analysis is not one specific algorithm. What constitutes a cluster and how to efficiently find them. Popular notion of cluster include group with small distance between cluster members, dense areas of data spaces. Reference 9, 10, and 11. Related work continues. Classification. It is a process related to categorization, the process in which ideas Ideas and objects are recognized, differentiated, and understood. 12, 13, and 14. Supervised learning. Supervised learning is a machine learning task of running a function that maps an input to an output basis on example input output pairs. It infers a function from labeled training data consisting of a set of training examples. 15, 16, and 17. Unsupervised learning. Too many approaches to solve the problem, such as in clustering k-image mixture models. DB-scan optics algorithms. Optics algorithm. Reference 18, 19, and 20. Index. From the unsupervised learning need how to efficiently find them. Popular notion of clusters include group with a small distance between cluster members, dense areas of data spaces, such as Kronig-Skarab index, Sled score, David-Burden index. Reference 21. Related work continues. Scikit-learn, one of the machine learning libraries from the 2007 till 2019, continuously update the version of the library. Reference 22. This library is using the Python and easily to implement the library. Proposed approach 3A, Sled score. Sled score is the easy way to in data I, each data cluster in data's definition on I, each data is the clustered inner and the data definition BI, Sled score SI is equal to calculated SI equal max AI and BI minus AI. From this calculate, SI is equal to the function minus 1 SI1. SI is the close to 1 is data is correct cluster to each thing. Close to minus 1 cannot distribute cluster is distributed. From this paper, machine using the machine learning library Scikit-learn in the household power consumption clustering 23, 24, and 25. Proposed approach 3A continues. Kronig-Skarab how to where to be clustering in a way is Kronig-Skarab index, Davis-Burdon index, Dunn index, Sled score. In this paper, evaluate via Kronig-Skarab index and Sled score evaluated. From the clusters, Kronig-Skarab index SI, the clusters distributed average and cluster distributed ratio will give it to you. SK, TR, WK, TRPK, K minus N minus K. For this, BK is a distributed matrix from each group. WK is a cluster distributed defined. Reference 26, 27, and 28. Proposed approach 3A continues. Davis-Burdon index. If the ground truth levels are not known, the Davis-Burdon index sklearn matrix Davis-Burdon. Rij Si plus Sj Dij, then the Davis-Burdon index is defined as db equivalent. It must have to change. Rij, the zero is the lowest score of possible. Score value closer to zero indicate a better partition. But the problem is algorithms do not attach it in the Scikit-learn library and only explain it in the document, but cannot explain it easily. Proposed approach 3B, reducing the data set. Proposed approach 3B continues. Evaluation, declaration, and resources. CSMPC configuration software. 3A, first paper execution snapshot. 3B, second paper execution snapshot. Analysis, K equal 7. From K-means algorithm, calculate proper cluster thing is very important. From the data estimated Sled score, the result is K equals 7. Each cluster centroid and data prices Sled score are 0.799 is the optimal score. From the former Kronig-Skarab index, result is 560. 399 is the optimal result. Using this K-means algorithm, the fact is figure 11. Software. The background software is Anaconda 3 and Python. This OS operating system is the Windows 10 Professional. RAM is 16 GB. Processor is i7 6600 CPU and 2.16 GHz. Hard disk 420 GB SSD. CSMPC configuration software. Dataset in UC Irvine Machine Learning Library. Scikit-learn CSMPC configuration software is using the dataset in UC Irvine Machine Learning Library. Scikit-learn Anaconda 3 is open source, personally can easily follow it. It's Scikit-learn is open source and Anaconda is Scikit-learn is open source library for the machine learning. It's coded by Python, and Anaconda 3 is the library bunch of library for the easily to install it. Open source personally can easily follow it, and because using the BSD license, it's following the open source policy and can easily modify from the real works don't have the modify easily to real works don't have difficulty to do that. People can easily to following this simulation and experiment. 3A execution snapshot. K equals cluster is K equals 2, cluster K equals 3, cluster K equals 4, and cluster K equals 5, cluster K equals 6, cluster K equals 7, K equals 8, K equals 9, K equals 10 result. Each only for the analysis of electricity consumption and machine learning electricity consumption for the machine learning library, machine learning dataset from the UC Irvine dataset, machine learning library, machine learning dataset. Because find the optimal value, optimal cluster is K equals 7, and we put the Shiller score and David Gordon index and then Kalinsky-Harvard index. Mix the three indexes to find the best cluster. The result is K equals 7. 3B second paper execution. A per 1 dataset K equals 1. A per 1 dataset K equals 2. A per 1 dataset K equals 3. Results. A per 1 dataset K equals 4. A per 1 dataset K equals 5. A per 1 dataset K equals 6. A per 1 dataset K equals 7. A per 1 dataset K equals 8. A per 1 dataset K equals 9. A per 1 dataset K equals 10. A per 1 dataset K equals 11. This is the reducing the dataset, and the result is the same with before. Conclusion technique. How to solve it. First point. We using the King's clustering algorithm and association with multiple answers. Electricity. Right side of conclusion. Published paper. This is the already published to the IEEE conferences, ICT 2019, and it's also uploaded from the IEEE library site. Function Ahmad Paskish and Dong-Yul. Analysis of electricity consumption at home using the King's clustering algorithm. IEEE ICT 2019, South Korea, 2019 Sungwon University, Korea. I published the submit the 3 papers to ICT, but accepted from the 2 papers. Association, bigger dataset, reducing dataset. The King's clustering is the high under the unsupervised learning, and then K-means clustering, and the SVM, and then some other machine learning algorithms. K-means algorithm is one of the clustering methods for the divided ways, giving the data among the many partitions. For example, receive data object and divided data is input data divided. Each group consisting of cluster below equation is the K-means algorithm when cluster consists of algorithms using the cost function used. Number 11, references. Kalinsky-Harvard index. serial score, Davis Bode index. It's among the using the three indexes and then analyze for the pick the best result for the pick the best result for the um, pick the best result for the machine pick the best result for the verification for, but the problem is algorithm do not teach. But the problem is this algorithm is not attached to scikit-learn library and only explained in the document page, but cannot explain it easily because in the Wikipedia in the wiki page, and then that is explained in the David Burden index and it's not implemented in the library. Actually, conclusions from the paper house power consumption via K-means clustering user library, which is scikit-learn. Now, the three open source clustering can easily follow it. And because using the base license to real world don't have difficulty to do that. It's installed from the PyCharm for PyCharm combined with Anaconda 3 open source, and that is BSD license, and real world is not difficult. Not only K-means algorithm, PC algorithm, but also SVM algorithm, etc. Extra other machine learning algorithms cluster can also do it. From this result, in real household power consumption, diverse analysis and electric transmission power can measurement period and estimate it. And each data using electricity consumption, it can be used for progress taxation, regional to regional demand, forecasting, maintenance of power plant, and facilities can do it. In the gas company can estimate via K-means algorithms, and also can estimate about the gas consumption rate via K-means clustering and index. Actually, I participate in TensorFlow forums, and then that is the gas company tries to analyze using the machine learning library and then estimate about the household consumption for the gas, and its best choice, best trial from the conferences. So I tried to using the scikit-learn library. Each leaves some similar with the TensorFlow, but each leaves some different with the TensorFlow and scikit-learn, and put the machine learning, put the user-defined dataset and user-defined dataset and put the user-defined dataset and analyze it. Why I choose the user-defined dataset is it's already cleansing and then sequencing data, because from the for the machine learning, and data cleansing is must have to needed, because if not cleansing data, and then it need labeled data is needed from the put the machine learning. But the best choice and best trial is the if someone uses the machine learning library from the Userbyte and don't have it's a real data because it's open data set, so it's not perfectly not fitting the real power consumption, but as an experiment and its best choice for the as an experiment and its best choice for the its best choice because personally like do not have uh, someone's workload and then it's very difficult to experiment alone and it need core with data cleansing and something like level data and find some best data set for the experiment and then it's difficult to find it and then uh, it's not perfectly and it's uncertain about the result for uh, for the machine learning for the machine learning for the clustering result because the uh, k-means clustering is not supervised learning, so it cannot estimate about the result. So unsupervised learnings is perfectly it sometimes uh, cannot analyze easily. Cannot k-means algorithm PCR algorithms 받을 수 있는 k-means algorithm and PCR k-means and PCR algorithms and others SVM is also a little bit it's wholly unsupervised learning. Why I choose unsupervised learning? Why I choose unsupervised learning and then it's really some for the I tried the experiment twice. And first is the first paper is original data set and finding some about the clustering result. This is level data and sequencing data. And using the current Scanner's index, it's using the index and then find the best fit for the clustering. The best fit meaning is the from the analysis. 공간 신청했는데 그걸 안 들어요. 네. 종이 이거 승인되면 드릴게요. 좀 이따. 대학